Right. Good morning, Year 10 Triple Scientists. Okay, so we're going to have a go at this today. I know Mr. Timothy's been doing most of them, but I'm going to have a little go today doing an extra topic for you, Triple Scientists, okay? Because obviously when it comes to science, you're going to have to do a little bit extra, okay? So what I've picked today is acids and bases. This is a Year 11 topic, which comes up both in double award and in triple award, but you guys have to know a little bit more. So I thought we'd start with this. So keywords today, if you want to make it like a proper lesson, because we are going to do a do now activity and I'm going to model a couple of things as well. So keywords today: hydrogen, oxygen, water, neutralisation and ions. Remembering that ions are an atom with a charge because they have lost or gained an electron. Nod a word, describe the terms acid, alkali and base and calculate the concentration of certain acids. Okay, so what I'd like you to do first, sorry because I'm looking at my iPad screen and looking at the screen, so my eyes are a little bit all over the place. So what I'd like you to do first is to kind of pause the screen and have a go at the 6 do now activity questions. Okay, obviously you've now paused the screen and I'm going to have a go at answering them, not have a go because hopefully I know the answers. So list all the planets in order, starting from closest to the sun. So we go Mercury, Venus, Earth, Mars, Jupiter, Saturn, Neptune, Uranus. If you wanted to put Pluto on the end, it's obviously a dwarf planet, but if you wanted to put Pluto on the end. Next question then, draw and describe an atom. So I would be looking for the nucleus with the positive protons and the neutral neutrons. And then a shell with the electrons. Okay, obviously I would be expecting you to label that electrons. We've got neutrons. The nucleus. So that would be you drawing and explaining it. Number 3 then, describe what is the function of a cell membrane. The function of a cell membrane is to control what exits and enters a cell. Name the 3 types of radiation. So that would be alpha, beta and gamma. These questions are kind of more tailored towards year 11 than year 10. Okay, describe what does exothermic and endothermic mean. Okay, so exothermic, a bit like the word suggests, is when heat energy exits. Okay, so in a chemical reaction, when heat energy exits. Endothermic then, the other way round, is when, again, heat energy, because thermic, temperature, enters a reaction. Okay? How is a camel adapted to its environment? Okay, so a camel lives mainly in the desert. They have large feet, so surface area in terms of their large feet. To be able to walk on the sand. They're a sandy colour to be able to blend in, so their colouring is an adaptation, and also that they have humps so they can survive a long time because they've got access to water. Okay, so I've kind of tried to come up with 2 questions from each of the year 11 topics. Okay, obviously you've already done a biology triple lesson and you've done a physics triple lesson, so today we're going to do a chemistry triple lesson. So what we're going to start with is the pH scale, okay? So if you wanted to make notes at this point, obviously pause it and you can make some notes as you go, okay? So pH, you've probably heard of the pH scale before, done it at not GCSE, Key Stage 3, maybe even in primary school, okay? pH is a measure of how acidic or alkaline a solution is, okay? A solution is something in water. So something in water, mixed with water. The pH scale goes from 0 to 14. Anything less than 7 is an acid. The lower the pH, the stronger the acid. So something that's got pH of 0 or 1 is a much stronger acid than something that's got a pH of 4 or 5, okay, even 6. Anything with a pH greater than 7 is a base or an alkali, okay? An alkali is a soluble base, okay? So something that will dissolve dissolve in water, okay? So anything above pH 7 is a base, only some of them then are alkalis because they're the ones that dissolve in water, okay? The higher the pH, the more alkaline the substance is, the stronger acids and bases have, stronger bases and alkalis have a pH of about 7. Neutral substances, so water, is exactly 7, okay? They're neither acidic or alkaline, okay? If you wanted to make some notes, that's great. Obviously pause the screen and you can make notes as you go. This is just a pH scale. Obviously, if we were in school, we do the pH test. We just use universal indicator, and you can add it to acids and alkalis. And then depending on the colour, okay, it kind of goes in the colours of the rainbow. Okay, so Richard of York gave battle in vain. So the ones at the end, so like Richard of York gave battle in vain. So that helps you. Red, orange, yellow, they're the acids. Then green is obviously neutral, and then blue, indigo, and violet are the alkalis or bases. Okay, so you can kind of remember it if you remember the colours of the rainbow. Okay, the stronger ones will be reds. And then obviously going up closer, this one here is neutral. That's green, and then above that is more purpley blue. Okay, just changes colour completely. You've most probably done it lower down the score. Okay, but there's just a picture. Obviously, we would have done it had we been in school. Again, that's maybe a little bit of a better picture. Commonly used indicator is the universal indicator. There are obviously other indicators, but the best one to use is the universal indicator because it's easy to work out the colours. It's a combination of dyes that gives you different pH values. It's very useful in estimating. Okay, it's not 100%. If you were looking for accuracies and talking about inaccuracies, we'd use something called a pH meter, which would give you an exact reading to a decimal place. So that would kind of be an inaccuracy of the universal indicator experiment. So this is just looking at different types of acids. So you can kind of see the strong acid, stomach acid, normal, rain is actually slightly acidic. Okay, acid rain then is more acidic. Pure water, so that means water that's actually undergone a process which had everything removed, all the ions that you'd find in the water that comes out of your tap. So even the water that comes out of your tap is slightly acidic. Don't worry about it, you can still drink it, but it's not 100% pure water, okay? Pure water would be something like deionized water that we get in the little big canisters, and then we put them in the little canisters in school. So that's kind of, if you wanted to make notes. I'm not expecting anyone to draw a pH scale, okay? But just so you've got an awareness of the pH scale, you will be asked, kind of comes up as the first question, what colour would a strong acid go on a universal indicator, stuff like that. So acids and alkalis. When a substance is an acid or an alkali, it depends on the type of ions, okay? So if they've got an atom with a positive or a negative charge, that is released when the substance is dissolved in water. So when you add an acid to water, H plus ions will appear. H plus ions will appear, and that's what makes something acidic. And then an alkali, OH minus ions would appear. Okay, so acids are H plus ions, alkalis are OH minus ions. Again, if you wanted to pause and copy this down in your notes, that's more than you can. Okay, so a little progress check. Again, I want you to press pause and have a go at these questions. Obviously, with you guys being high ability, our triple scientists, I'd like you to correct the ones that you think are false. Okay, so correct the ones that you think are false. Obviously, I'm going to carry on now, but you press pause and have a go at answering them. So, first question, acids have a pH lower than 6, okay? So that one is true because they don't have pH 7 is neutral. So you can't be pH 7, they have to be lower than 6. Neutral substances are pH 8, that's false, okay? So it should be pH 7, okay? Notice when you write pH, the P is small, lowercase, and then the H is a capital letter. Bases are soluble alkalis, that's false, it's the other way round, okay? Alkalis are soluble bases, remembering that something that's soluble is something you can dissolve in water. Red indicates a weak acid, that's false, okay? More yellow would indicate a weak acid, red would indicate a strong acid. Acids contain H plus ions, again that would be an alkali, so H plus ions, or you could change it the other way around to put alkalis contain OH minus ions. Okay, so that was just our first progress check of 3, checking you've kind of understood what I've talked about in terms of the pH scale. So, moving on a little bit on state symbols. You've most probably seen these in year 10. They kind of come up in chemistry and a little bit in physics. So these 3 are nice and easy. So if you see an L, sometimes we'll write like H2O with a little L. Not very good. with a little L in a bracket like that, that means that H2O water is a liquid. Okay, we might write H2 as a gas, and that means that hydrogen is a gas. Okay, if you've got calcium on its own, that might be a solid. Okay, so that's how we use state symbols. This one then means aqueous, which means anything dissolved in water. So when something's mixed in water. Okay, so something like Ca2, okay, that would be aqueous because that's calcium dissolved in water. Okay, so just so you've got an awareness of them state symbols, because they sometimes come up, especially with acids and alkalis. Finally, then, for the next little bit of the before we do another progress check, neutralisation reactions. Okay, so neutralisation reactions are when you've got something that's got a pH of about 1, something that's got a pH of about 12. You add them together, and then they neutralise to the middle value, pH 7. Okay. So imagine it a little bit like a seesaw, and you want to get to the middle, which would be pH 7. An acid will react with a base, it might be an alkali, it just depends whether it's been dissolved in water, to form a salt plus water. This is called a neutralisation reaction. So when you add an acid and a base, you make water, which have pH 7, you also make a salt. The general equation for neutralisation reactions is shown below. Again, we will at some point go through a lot more detail about how you name these salts, but for now, we just want to know an acid plus a base makes a salt plus water. Okay, so don't worry about naming the salts at the moment. Just know that when you add an acid to a base, you make a salt plus water. The water is what it then gives you that pH value of 7 because it is neutral. You can kind of show that just in terms of the active ions. So the acid, so that's essentially the acid ion. That's the alkali or the base ion. And you add them together, and that's where the water comes from. So the water comes from the acid and the base, the ions that make them acidic or basic. During neutralisation reactions, H plus ions from the acid react with OH minus ions from the base to produce water. Okay, this is quite important. It comes up quite a lot on higher, just being able to write it down. If you notice, as well, we're talking about state symbols, aqueous, that means they must have been dissolved in water. H2O is a liquid, so you can see the use of state symbols there. Okay, that's just essentially the word equation there, and then that would be the symbol equation. So that's a symbol for acid, that's the symbol for base, and then when you add them together, you make the water. And then this is just talking about how we could do the experiment. So if I had something that was acidic and something that was basic or alkali, the indicator should change colour over time. So you might have, if I had 2 jars, I'd have one that was red, one that was blue because I had the indicators into them. If I added them together and they neutralise each other, it should turn green. Okay, that shows that a solution has become neutral. So it's one way of testing that you've got a neutral reaction and a neutralisation reaction has taken place. Right, I will try and edit my dog barking out. If not, that was just what was going on then. My dog was barking. So, next little progress check. Okay, obviously you can pause the screen. I'll also put the PowerPoint up on Teams. I'll kind of move it around just because the amount of questions I've kind of put on here for you, just to check your knowledge. So just to kind of move it around a little bit. So there's the top kind of 4 to pause on. And then there's the next question to pause on there. Okay, so obviously you'll have paused and gone written down the answers. So I'll now go through the answers. Sorry, because I got to look down at my iPad. So, what is pH a measure of? pH is a measure of something, whether something is acidic or basic. If a solution is neutral, what pH is it? It would be pH 7. What ranges of pH show that substance is a base? 8 to 14. What is the difference between a base and an alkali? Alkali is a soluble base. What type of ions makes solutions acidic? H plus ions. and then alkali would be OH minus ions. What state symbol is used to show substances dissolved in water? So that's brackets AQ, which would be aqueous. What is the product of the reaction between H plus ions and OH minus ions? That would be H2O. Write a symbol equation for this reaction including state symbols. So you've got your acid, which would be H plus ions, which is aqueous, plus OH minus ions, which is your base or your alkali, and then that makes H2O, which is a liquid. Okay, so moving up then to the next couple questions. Circle either acidic or alkaline for the solutions. So a solution of hydrogen sulfide has a pH of 4.2, so that would make it acidic. A solution of calcium carbonate has a pH of 12.4, so that would make it alkaline. After adding universal indicator, the solution changes colour to yellow, suggests the solution, pH of the solution. So yellow, we're going to be looking at about pH 5 to 6, okay, because it's going to be a weak acid. Another solution has a pH of 9, suggests what colour it would go, so that's going to be a blue colour, okay. The higher up the alkalis are, the more alkaline they are, so that means they're stronger. So pH 9, that's going to be a bluey colour. Okay, state symbols are the following compounds, so that's got a little G, so that's a gas, that's a liquid, that's aqueous, and then that's a solid. The base of calcium carbonate reacts with hydrochloric acid, so a base reacts with an acid. Okay, so what type of reaction is that? That's neutralisation. A salt is formed, what's the other product? That's water. Okay, so remember we did acid plus a base equals a salt plus a water. Okay, so that's kind of 2 progress tests, just going through the pH scale, going through what acids are, what alkalis are, looking a little bit at state symbols and neutralisation. So finally, we're going to look a little bit at calculating the concentration, where you can do it of alkalis, but we mainly do it in science of acids, because acids just tend to come up with more concentration, but it's exactly the same thing if you had an alkali. So think about it like squash. If something's really concentrated, it'll be really strong in colour. Okay, you'd see it, they'd have loads of squash particles in it. If you've got really dilute squash, you're going to see it's going to not be as, it's going to be quite weak. You most probably won't see as much colour, and that means it's got less squash particles in it. So exactly the same when it comes to acids. Concentrated solution contains a large amount of solute per litre of solution. So this means that there's a large amount of H plus ions if we're doing acids. So a large amount of the acids in the solution tends to be if it's been dissolved in water, okay? They've said strong coffee. You think about it like squash, really concentrated squash. There'll be loads of squash in that volume of water. Dilute solution contains a small amount of solute. So this again, these are the H plus ions. If something's dilute, it's not going to have much in there, okay? Look, they're both the same volume of water. It just depends how much is in them, okay? And there is a little equation that you can do to calculate the concentration of certain acids. Like I said, you can do it with alkalis, but we tend to do it more with acids in science. So that's the equation. If you want to pause the screen and look at it, obviously I've done it in a triangle, okay, because I know some of you find that quite easier, but I've also just done it. So moles equals concentration times volume. So the last kind of week or so, you would have done it in year 9 as well, the last kind of week or so before we went off, we started looking at MR and moles in chemistry. So it's just going to kind of do a different equation for working out moles that you use as triple scientists, okay? You might never have seen this before, okay? So that's decimeters cubed, okay? So all volumes in chemistry are measured in decimeter cubed. If you get a volume in centimetres cubed, all you have to do is divide by 1,000 to convert it to decimeters cubed. Okay, so watch out for that. That's going to be most probably the biggest thing that's going to set you off when doing these concentration equations. Okay, so just if you wanted to make notes of that or whatever, obviously you'll have the PowerPoint. I'll put it up on Teams, so you don't need to worry too much. So I'll go through 2 and then I'm going to leave you get on with loads and then I'll mark them when they go up on Teams, okay? So this is just from a PowerPoint I would have used had we been in school. So 0.5 mole of solution is dissolved in 250 centimetres cubed of solution. Calculate its concentration. So on the question, like we do before, highlight what we already have, okay? So we've got 0.5 moles, which means that we've got our moles, we've also got our volume, and it's asked us to calculate the concentration. So highlight what we have in the question. Just read through it, highlight what you've got in the question. Make sure your volume is measured in decimeters cubed. Now our volume isn't, it's measured in centimeters cubed, so I need to do 2,250 divided by 1,000. Unfortunately, I haven't got my calculator because I left it in school, so I'm going to use my trusty iPhone. Okay, it won't be as good, okay, but I appreciate that some of you might not have scientific calculators at home, so you might have to use your calculator on your phone. So just did that. Most of you have been able to do that in your head, okay, but in science you do get a calculator, so if you want to just check your workings, like I just did then, if you just want to check your workings just to be sure. So I've made sure my volume is measured in decimeters cubed. Write out the triangle for calculating concentration, so if you wanted to go back and look at it, I think I might just use the equation because it's a nice easy equation. So moles equals concentration times by volume. So we want to calculate concentration. So obviously I could use the triangle, cover up concentration, so be moles divided by volume. Obviously we're quite good mathematicians now, so we might just want to rearrange it. So moles divided by volume would give you the concentration. So it's up to you how you want to use it. If you feel more confident using the triangle or you just want to rearrange the equation, it's up to you. Use the information to fill in the equation with what you have. So we know that our moles is 0.5. We know that our volume, now I've converted it, is 0.25. And I'm going to work out the concentration like this. Okay, again, I'm going to use my phone just to check. Okay, again, you might be able to do it in your head, but you're just going to check what you have got. Okay, and that gave me 2. Okay, so the concentration is 2. Okay, like I've said, check, use your calculator. Just going to go back to my triangle. Okay, might be worth writing this out when you're doing it or holding the screen on it to check my units. The units for concentration are moles per decimeter cubed. So moles per decimeter cubed. Okay, you can kind of see that anyway because you've got moles there, got decimeter cubed there, so you can kind of work out the units anyway. Okay, but really important you check your units. Okay, so I'm going to do one more and then I'm going to kind of leave you to have a go at quite a few on your own. So one more now, this is a little bit different. So calculate the moles of solution when 2 decimeter cubed is dissolved in a concentration of 0.1. Okay, so highlight what you have in the question, work through the question, highlight what you have. Make sure your volume is in decimeter cubes. Now this time it is in decimeter cubes, so we're quite lucky. Write out the equation triangle. Like I said before, if you want to go back and check, then by all means go back and check. Write it out every time. I'm just going to write out the equation. So moles equals concentration times volume. Okay. I says they're calculating concentration because that's what the equation is known as. So we don't need to rearrange this time because it says to calculate the moles. So fill in what we have. So we've got concentration of 0.1 and we've got a volume of 2. Okay. Calculate using a calculator again. You might be able to do that in your head, but I would just suggest you just check. Okay. So I'm just checking on my calculator. Okay. Can't do that in my head, but I just think it's worth checking. Okay, so 0.2. Again, go back and check your units. Okay, the units for moles are just mole or moles. Okay, but check your units. So, just going to load. Right, so there's quite a few questions to have a go at. The first exercise is just to convert volumes into decimeter cubes. Okay, just looking at it. And then there's some calculating the concentration and some calculating the moles. Okay, so that's what I'm going to ask you to kind of have a go at now. Would you like me to? I'll tell you what I'll do. Okay, I'm going to pause this. You have a go at it, and then I will put the answers up. So I'll pause my screen as well. So you've got the answers going to flash up in a second. Right, really quickly then, those are the answers. So if you wanted to pause the screen and have a look at the answers, check what you've got. Remember to upload it two teams so I can just check that you've done it. Okay, you can make your notes however you want, but I want to see that you've done some work. Okay, let me know as well if you like this way, and I can do another one for the triple scientists next week. So I know Mr. Timothy's doing one for all scientists, which you've still got to do. But if you want me to do another one next week, I think we're back on biology if we're rotating around. So if you'd like me to do another one, you can just let me know either on your work or give me a quick email. Thank you very much. Bye.